Hello and welcome to this presentation covering basic plotting in MATLAB. Thanks so much for watching. So what I want to do in this video is just basically show you how you would generate kind of a typical plot of a function. We're going to do the function f of x is equal to x squared. We might also do like f of x is equal to sine of x or something like that. You know, just do a couple to kind of show you. But basically, what I want to do is just show you how to plot basic functions in MATLAB and use all the different features that, or use at least some of the, I guess, basic features that MATLAB has to generate kind of nice looking figures that you could stick into a report if you were typing up a report. So anyway, I've got my MATLAB window open. I have my editor, my figure window, my command window, and my workspace open. If your window doesn't exactly look like this, it's not a big problem. You don't have to have all these open, obviously. The big thing that we're going to spend most of our time working in is the editor, and then also, clearly, we're going to produce a figure that's going to pop up in this figures window that we have. So where I'm going to start my script off is I'm going to start off by clearing all of my variables. I do that with the command clear all. So basically what that does, if I had any information stored in variables, it just clears them all out. The next thing I'm going to do is I'm going to close all of my open figures. I want to start this script off with a clean slate. So if there are any figures open from previous stuff I had done in MATLAB, I want to close them. And then the last thing I'm going to do is I'm going to use the command CLC, which is going to clear anything that is in my command window. So if I type A equals 8, B equals 17, B equals 17, something like that, and then I type CLC, it just clears all those commands. So let me run this real quick. On a Mac, I can run code that's in my editor window by typing Command Enter. On Windows PC, you can run the code by typing Control Enter, and I'm pretty sure it's the same on Linux if you're doing this on Linux. If you hold down Control and push Enter, that'll run the code that is in the current that's in the current cell of your editor's window. So anyway, what we are going to be doing is we're going to be plotting out the function f of x. So we're going to plot f of x is equal to x squared. That's what we're going to try to do in this video. What I want to do just for a second, I want to take a quick aside and just kind of describe what MATLAB does. So in this video, kind of the main command that we're exploring is the MATLAB plot command. And what you have to pass this command, there are a number of different things that you can pass it, but and you know, you don't always have to call this function in the exact same way as I'm going to do in this video. There are kind of a number of different ways you can call almost all the functions in MATLAB. But for this plot command, basically what we are going to pass in is we are going to pass in a vector that contains points, x points that we want to plot, and then separate them by a comma, another vector that contains, that's not a very good y, that contains all the y points that we want to plot. So pretty much this x vector, it's going to be basically just a list of points. It's going to be, you know, 1, 2, 3, 4, something like that. It's just a list of points that are telling me, okay, these are the different x coordinates I want you to plot. And then the same thing goes for the y vector. The y vector is going to have, you know, different points as well. Let's say that they're, I don't know, 2, 1, 0, 3 in this situation. Let's just say I pass this in to the plot command. What the plot command is going to do is it's going to match up this point and the corresponding x point with the corresponding y point. And let me go ahead and I'm going to draw out my axes. Plot window is going to give you some axes, or else it's not. The axes, I guess, are assumed to be on the frame of the figure. But let's say that this is 1. That's 1, 2, 3 on the y, and we've got 1, 2, 3, 4 on the x. So this is this is y, and this is x. And pretty much what the plot command is going to do is it's going to match up this x with its corresponding y. And so this is at 1, 2. So we're going to start here. And then it's going to draw a line from that point to the next point. So the next point is at 2, 1. So this is 2, 1. So we are going to start off drawing that straight line that connects these 2 points of our vector. And then we're just going to keep going through this. So the next point we have is 3, 0. So that's at 3, 0. So we're going to draw another straight line that connects us between these 2 points. And then we've got another straight line that'll connect us to the point 4, 3. So that point is right here. So if we were to pass in this x vector and this y vector into our plot command, this is pretty much the plot that we would get. We would get, it's not going to draw circles. I've kind of drawn these points at each of the points, but what the plot command is effectively going to do is it's going to connect each of those points with a straight line. One of the things that I've seen people do before is they say, oh, well, if I just want to plot x squared, I can just say plot, open paren, x caret 2, and that should plot x squared. And anyway, hopefully we'll see in this video that what you have to do if you want to plot a function out is you have to pass in an x vector and a corresponding y vector. Notice also that these two vectors have to be the same length. They have to have the same number of elements, because what the plot command is going to do is it's going to match up the corresponding x coordinate with the corresponding y coordinate and then use that to generate the plot. So anyway, with that out of the way, let's go back to the video. So in order to do this, I'm going to need to start off with an x vector, because keep in mind, I'm trying to plot f of x is equal to x squared. So for all the different coordinates that I want to plot this out, for everywhere that I want to define x squared, I'm going to need to start out with an x vector. Notice here that when I passed in 1, 2, 3, 4, and y was my f of x variable, everywhere I wanted to plot this function, I needed to define where my x variable, I needed to define those points in my x vector. So let's go ahead and do that. I'm going to start off using a command in MATLAB, a built-in function in MATLAB called Linspace. This function takes it can take a number, as all the functions in MATLAB kind of do. It can take a number of different arguments, and as you can see, I've got this little box that popped up that is prompting me on the arguments I can put in. But what you can use Linspace to do is you can use it to generate a vector that's suitable for using in plotting. And what you pass into Linspace is where you want your vector to start from. What is the first x coordinate that I want to define? Let's say I want to start plotting out x squared. Let's say I want to plot it on the limits, plot f of x equals x squared on limits on x limits. Let's say x limits from -2 to +2. So I want to plot out f of x equals x squared from x is equal to -2 up until x is equal to +2. So in the Linspace command, what I can do is I can pass in where I want to start the vector from, which is -2, where I want to end the vector, which is +2, and then how many points I want to define in that vector. So, actually, you know what? Let's start off. We're going to define too few points. I'm just going to get a vector that has, let's say, 5 elements in it. Okay. So what I'm going to get from this is an x vector using the Linspace command that goes from -2 up to +2. That is going to have 5 equally spaced elements in the vector. Let's actually, and I'm going to not put a semicolon at the end of this because I want to print out what this vector is to the command window. I'm going to run this real quick. So anyway, as you can see, I've gotten now my x variable is now a vector that goes -2, -1, 0, 1, 2. Okay, and I'm going to actually run this again, but suppress that print output by putting a semicolon at the end of my Linspace command. Run it again, and now I just don't get any print output to my command window. So anyway, now I've got my x vector. And you might not see it right now, but I have defined too few points in my x vector. I only have 5 points, so my plot, well, you'll see in a sec, isn't going to look that great. So anyway, now let's define my f of x. So I'm going to say, let's actually just call it y. Or actually, plot, I'm going to say instead of f of x, let's plot y equals x squared. So I'm going to say y is equal to x squared. And now I'm going to run this, and I'm going to get an error because what's happening here is, keep in mind that like what MATLAB kind of does, and the big thing that MATLAB was designed to do was linear algebra. It was designed to do matrix multiplication, matrix operations. Basically, all of your variables in MATLAB are matrices and vectors. And pretty much all of the arithmetic operations, multiplication, division, powers, are all assumed to be matrix operations. So keep in mind, if x is a matrix, the dimensions of x right now is a 1 by 5 matrix. So when I say x squared like this in MATLAB, it's trying to do matrix multiplication of x with itself. So if you've had a little bit of linear algebra, and I would say if you are trying to use MATLAB and you haven't had linear algebra, you're going to need at least a little bit of linear algebra in order to use MATLAB effectively. It would be a really good thing to check out some videos on the Khan Academy, just kind of giving you a little bit of an introduction into linear algebra about how basic matrix multiplication works. But if you have had linear algebra, you know that if I want to multiply two matrices together, their inner dimensions have to agree. So if x is right now a 1 by 5 matrix, I have one row, 5 columns. So it's a 1 by 5. If I try to I can't multiply a 1 by 5 times a 1 by 5 matrix, right? That's not defined. I would have to multiply a 1 by 5 times a 5 by something matrix in order to have that operation defined. So instead of doing matrix multiplication, what we want to do is a point-wise operation. Basically, what we want to do is we want to take each of our elements in our x vector and multiply it times itself. This, particularly if you're doing a lot of plotting for reports, is a very valuable thing to know how to do in MATLAB. Know how to make MATLAB do point-wise operations, even on very large and very substantial matrices. So anyway, if I run this, now the code is basically fine. And because I have, I only have 5 elements in my x vector, my y vector is also only going to have 5 elements, so I can even print these both out. So notice, if I want to print these out to the command window, I just get rid of the semicolon, hit Command Enter, and they both print out. So you can see -2 squared is 4, -1 squared is 1, 0 is 0, 1 is 1, and 2 squared is 4. So anyway, we can see that this is working. So now let's go ahead and plot these two vectors. So what I'm going to do is I'm going to get myself a new figure, and I'm going to say that I want a new figure. This is going to be the first figure, so I'm going to say figure, open paren, 1, semicolon, and then just right on the same line, I normally put my clear figure command, my CLF command that just kind of clears the figure. let's also, I'm going to give my figure actually a variable name. I'm going to call my figure fig. Um, so now anytime I want to reference my figure, I can just use this fig command. Just use this fig variable, my figure variable. So now inside of my figure, what I want to do, and I guess let's just start out with the most basic thing. And even actually, I'm going to leave off I'm not going to store my figure variable right now. I want to do just kind of the most basic thing. What I'm going to do is just plot out those two vectors. So I'm going to say plot my x vector, comma, my y vector. That's always what you put into the plot command. What is going to go, you plot the vector that defines your x-axis and then the vector that defines your y-axis. Close paren, and now if I run this, I open up a new window, and I can dock that window by clicking this arrow. There. So now my figure is docked. Almost. There it goes. So now my figure is docked. I've got my first figure, and I've plotted my xy vector, and you can see that it kind of looks like y is equal to x squared, but it's real boxy, right? It has these really sharp points right here, and it's, you can see that I'm drawing these straight lines between each of those points that I've defined. So the way I can get rid of that is by defining a whole bunch of points inside of my my x vector. So instead of 5 points, let's go ahead and I'm going to put in 10 points. So I put in 10 points. Actually, this close all is getting kind of a little irritating. I'm going to get rid of my close all, and I am going to dock my figure again. There we go. So I run this again, and now if I have 10 points instead of 5 points, I get a much smoother graph. Even though you can probably see that I still have these kind of sharp corners down here. And I can get rid of those by saying instead of 10 points, how about we put in 100 points? And then I can run that again, and you can see it smooths it out. Typically, a typical number of points that you might put into a MATLAB plot is about 10,000 points. One of the things that you do have to be a little bit careful with when you start plotting with 10,000 points, you have to be a little bit careful that you're not going to print out those vectors to the command window, because that can take time just to print those vectors. But a typical number of points that you would plot in MATLAB is about 10,000. And the way I normally put that in is 1e4, which basically means 1 times 10 to the 4th power, which is going to give me 10,000 points. So if I run this, I get a nice, smooth graph. So anyway, that is pretty much it for really basic plotting. In the next video, I'm going to just go over some stuff. They'll show you how to put in a title up here, how to title both of your axes, and maybe even how to save the figure. So anyway, thanks so much for watching, and I'll see you in a future video.